Hello and welcome to another tutorial for BlackHole.Core.ORM. The previous video was 3 months ago and it was about the version 6.0.2 and 6.0.3, but now we have 3 new versions with many new features, with the introduction of a new type of entity and a new data provider that we're going to see in this video. As you can see, these 3 versions were released almost at the same day, and they are identical, and the only difference is that they refer to a different .NET version. The 6.1.1 is for .NET 6, the 7.1.1 is for .NET 7, and the 8.1.0-RC is a pre-release for .NET 8. I am going to release the 8.1.1 when the .NET 8 will be released this November. We are going to continue to work on the tutorial project that we made in the previous video. So if you didn't watch the previous video, you have to watch it to keep up with the tutorial. And today I am going to use SQL Server for our database because I didn't use it in the previous video. And also I want to tell you that I don't have Docker anymore because Docker was taking so much space into my main drive, and I couldn't find a way to relocate Docker into another hard drive. So I have set it up Debian virtual machine here, and I have set it up all the databases into this virtual machine. Let's jump to our project. And if you remember, we had a controller, we had a service here, an interface, we had some entities, we had some DTOs, we had some other entities here, this one, for example. And I think we had somewhere we had a generator. I think the data generators are in the service. Yes. And here on the dependencies, we can see that we have some packages, and we have in the packages the BlackHole.Core.ORM 6.0.3, which we are going to update it today. But first, let's take a quick look to our code here, and let's go to the errors, and you see we don't have any errors here. And I'm doing this because I want to show you that when we update the version of the BlackHole, everything will keep working in every version of the BlackHole. I don't change the methods or the way that things work in order to not break the code of existing applications that are using a previous version of the BlackHole. So let's go here. The first thing I want to do is to go manage NuGet packages for this solution, for this project. And if we go to the installed packages, we can see we have the BlackHole.Core.ORM here, and there are updates here. There's an update or more updates available. And since we are using .NET 6 in this project, I am going to use the version 6.1.1. And as you can see here, it also says that version 8 is a pre-release. And all right, let's select this one, 6.1.1, and click update. And here we are going to see that it updates the SQL clients for its database. I've tried to use the latest available for its version. Also, it uninstalls this. This may be a dependency of a previous version of some client. Let's click apply and accept. And now we have, now we have the version 6.1.1. And here we can also check on the dependencies that we have this version. We can go to the error list. Let's close this one. And we don't see any errors. Let's rebuild also the project. Let's rebuild to see if there are any errors, if it breaks something. I am using a preview version of the Visual Studio, that's why it's a bit slow. As you can see here, it's a preview. Okay. And the reason for that is that .NET 8 is only available on the preview, the .NET 8.0-RC pre-release. So I had to update to this preview in order to create the version of the BlackHole for .NET 8. So I have already changed the connection string here to point to the new database server, SQL Server, which is in the virtual machine, and also have changed the database type here. All right, and since we already have a database here, I want to drop it. I want first to drop it, and then we are going to create a new one. So I am going to use the BlackHole CLI, and as you can see here, we are in developer mode already, so we don't need to use the force argument in our BHL drop command. If you missed the previous video and you don't know what I'm doing here, go watch the section about the CLI in the previous video. So I run BHL drop and I expect to drop this database. So it's building the project now, and we can see the connection string and the directory of our project here, and it says database was successfully dropped, exit code 0, which is success. And let's go to our SQL Server and refresh here. Let me give me a moment. Refresh here, and the database is gone. BlackHole CLI works with every version of BlackHole from 6.0.1 and above. So you can see you don't need to update anything. If you already have the CLI installed, it will work with the new versions as it is. So we have dropped the database with the CLI. Let's clear. And now if I run the project, in the previous version it would create a database and it would create the tables and the columns and everything. But now, for safety reasons, for protection of the database, I stopped the automatic update, and it doesn't automatically update the tables and the columns. And if you want to activate the automatic update, you need to go here to the settings and add .automatic update, and this will set up an automatic update. And of course the developer mode is still used for giving permission to BlackHole to drop columns and tables. No, tables, it doesn't drop tables yet, but it drops columns, and it can also make some nullability changes to the columns if you have developer mode enabled and you want to make nullability changes. So I will delete the automatic update here, and I'm going to run the project. And before I run the project, I want to tell you that if you run here the BHL update command, if you run an update from the CLI, even if you don't have the automatic update here, it will create the tables and the columns, and it will update the database. But if you just run the project without the automatic update, it will create the database, but it will not create any tables or columns. Let's run this, and we expect to see in our SQL Server, we expect to see the database with the database name to be created, but without any tables. So let's wait for it to start, and here we can see the Swagger. And if you remember, if you have watched the previous video, you can see all the endpoints that we made. And if we go to the SQL server, let me close this list here because for some reason the UI doesn't update. And you can see we have the database here. And if we go to the tables, we expect to have nothing here except from the system tables. So we can stop now. I don't know why they moved the stop button here, or did I do this? Maybe I did it by accident. And let's go and add the automatic update, and let's save and run the project again. And now we expect all our entities to be translated into tables into the database. So let's wait for it again to run. And again it runs, and let's go to our SQL Server. Let's refresh and open this, and now we can see our tables. If you remember, we had these 5 tables in the previous tutorial, and you can see we have the same columns inside with the same constraints. So also I want to show you at this point that because SQL Server and SQLite support also names with double quotes around, like the Postgres and the Oracle, I have added also the option, if you want to make an SQL Server with double quotes around the names of the tables, you can just add true here. And if we go here to the description of the method, you can see it says you can add, there's an overload here with a boolean that says quoted DB. So I have added 2 overloads, one for the SQL Server and one for the SQLite, that allow you to create a database with double quoted names. So then if you want to run a custom command, you will need to add double quotes around the names of the tables and the columns. Also, with this overload, you can still use a schema. So let's say eShop schema here, and you can have also a schema and double coded tables naming, but we're not going to use it in this video now. And let's see the protection that have been added to the database in this version, because I've made a lot of changes into how BlackHole updates the database, and I also used a try-catch method into the SQL, which prevents changes if something fails in the update. And this includes also the DDL commands. DDL commands are commands that cannot be reversed in a transaction, and its DDL commands are the create table or the alter table or alter column commands, which make changes to the database. And with the try-catch method in SQL, it also prevents those changes if something goes wrong. And this try-catch is supported into SQL Server and SQLite, and not SQLite, in Postgres. In SQLite, the transaction works and it doesn't make changes even if they're DDL commands. But in Postgres and SQL Server, I'm using a try-catch method to prevent this from happening, to prevent changes from happening if anything goes wrong. And in MySql and Oracle, which they don't support the try-catch, I have made BlackHole, creating the reverse command for every command it makes. So if something fails at the update at some point, then BlackHole takes the index of that command and then runs the opposite command from that point and behind. All right. So this protects the database if you have any errors, any mistakes. It will throw an exception and it will not make any changes to your database. And to see that, let's go here to our entities. And right now, we have the table of the customer. Let's add a not nullable column, all right? Public string, and let's say middle name, all right? Get set equals string empty, and let's say this is a not nullable column. Not nullable column, all right? So this will throw an exception in the first check of the black hole. So you want to add a not nullable column to an existing table, and we are not going to be in developer mode, and I will explain soon why. So if you are not in developer mode and you try to add a not nullable column to an existing table, BlackHole will throw an exception, and this exception will tell you what you have to do in order to add that not nullable column. So let's run, and we expect now, with the automatic update, we expect BlackHole to throw an exception. And I know it sounds a bit confusing, but I will explain everything soon. So we got this exception, and it says property middle name of entity customer requires developer mode or update CLI command with force argument to be added as not nullable column on an existing table. The default value of it will be a dash. You see here it shows a little dash. All right. So why I made this? Because if you want to add a not nullable column and there's already data on the database, it cannot create a not nullable column to a table that already exists and has data inside, because it will not know what to put in this column. So depending on the type of the column, I have some default values inside BlackHole that will be applied to the column. This will not be a default constraint. It will just create a nullable column, then it will update the values with this value, and then it will turn it to not nullable. So because the user has to know what's the value that will be added instead of null to the column, I made this as a warning So if you want to change the newly created values, you know that you have to replace this to update the table where the new column has this value. So let's stop it and let's go back to the customer. Let's comment this out and let's create a customer first. Let's insert a customer first to the database. Let's go here and select all the customers, all the entries of the table. Then I'm going to run the application. Right, we can see these are the columns of the customer right now. I'm going to run the application now. I'm going to use the API, the Swagger, to add a customer with the generators that we have made in the previous video. All right, and as I remember, this method here, this endpoint creates a customer, and let's execute this. And we got a GUID ID as a response. That means our customer has been added, and if I execute this again, you can see we have a customer here. So now what we have to do in order to add this new column is, first of all, we need to uncomment this, and let's put only this into comment. All right, now let's run the project again. This will create the middle name column. All right, first we'll do this. We're going to run the project to create the column. All right, let's make sure the column was created here. Let's run again, and yeah, sorry, I have the previous query here. Let's add a star here and execute, and now you can see we have the middle name column, which is null. And now we are going to uncheck this. All right, and we're going to make sure here we are in developer mode. All right, and let's run this, and now it should update this column to not nullable. So let's wait for it to run, and it opens. All right, let's close it, and now if we run this again, you can see we have the dash here, and the column has been updated with the expected value. And if we go to the constraints, no, wait, if we go here to the columns, we can see that the middle name, where's the middle name? Let me refresh. Oh, SQL Server. The middle name is here, and it's not null right now. And now let's move to the new features of BlackHole. Let's say we want to create another entity here, and now we are going to use the new open entity. So let's add a class here, and what could we make as a new entity? Let's make a product. All right, I don't think we have a product table, so let's make a product.cs. Let's add it here to our entities, and this one I am going to make it an open entity. So using BlackHole entities again, and instead of B8's BlackHole entity, I am going to say B8's open entity. And here it requires a type, and as you can see, it says self. So it requires the type of product, the type of the entity, and it's still red because it has an interface also. So we have to implement an interface here and a method from the interface, because this is an interface. If you noticed, it's not a class, like the other ones. These are classes, but this one is an interface. And the reason I have made the open entity an interface is because I need to include the entity options. So let's add some values here. Let's say public integer product ID. So this type of entity, which is an interface and it's not a class, it doesn't have any other properties inside it, like the black hole entities, which contain the ID property and the inactive property for these columns here, for the ID and the inactive columns. So this entity has only the properties that user adds inside it. And if you want to check this, we can go here to the controller. All right, do we refer here the entities? Yes, all right. And let's say var product equals new product. All right, and let's say product dot, and we can see here we have only the properties that we have added and the method of the entity options. So the user has full control of the properties of this entity, and this method here, the entity options, helps user to determine which column or columns will be the primary key of this entity. So we can go here and say, as we can see here, we have entity options method and entity options builder of type product, which is the builder of the options, and entity settings of type product, which are the settings that this builder will return. We cannot instantiate the entity settings. It has an internal constructor, so you cannot just return new entity settings here. All right, you can't do this, and the only way to return entity settings is using builder. So builder dot, and here we have the option to set primary key. Also, we have another option to say this table we don't want to have any primary keys. So if we say no primary key, we're done. It will create a table in the database without any primary keys. But if we want to add the primary key, we can say set primary key. And here we will decide which one will be the primary key. Let's say I want the product ID to be our primary key. Also, because this product is an integer and this works with integers and longs, with integer and long types, we can add an auto increment. We can add a boolean here, true, and as you can see here in the explanation, it says has auto increment, and this will work if your primary key is integer or long. All right. Also for SQL Server and Postgres, it would work for GUID. It would add auto increment for GUID, but it will not work for anything else. If you use a GUID here, let's say I have a public GUID product ID true gets set. I can use also the auto increment into the second GUID. You can see the overload here accepts this. If I use another property, for example this, you see we get an error because this method can only work for integers, GUIDs and longs, but in GUID, if you are on another database except SQL Server or Postgres, it will be ignored and it will not, you may not get any errors here on the method, but it will not add an auto increment on the database. But now we are on the SQL Server, and I want to show this with an integer for now. So we can do this, and now the primary key column will be the product ID, and it will have auto increment. If we don't add auto increment to true, it will not have auto increment. It will just be the primary key of the table. Also, we can add a secondary primary key, a composite key. So we can add the composite key, and let's say that the product code is our composite key. So we will make a composite key with the product ID and the product code. And to point to this composite key, we need to make a composite foreign key if we want to add a foreign key to this table. Also, another thing we can do is, let's go quickly and create, let's go to the generic objects, all right? And let's add a class here. And let's name it string value generator, all right? And you see by the name where I'm going with this. So let's go here, and now I'm going to show you another feature of the BlackHole, and we can say here, we can make this class inherit from the IBH value generator of type string, for example, all right? And it's also in the BlackHole entities, as you can see here. So let's implement the interface, and it has a method which says generate value. And here, let's say we want to return the datetime now, datetime.now to string. And now we have a generator that it will run every time that we insert into our table an entry, right? But how we can set this generator? Let's go back to our entity. I know it's a bit confusing how I saw these things. And here we have an overload again for the composite key. We can also have a generator here. We can have a generator everywhere, and we can say new string value generator, all right? And now every time we insert something into the table, the generator will run the method that has inside, and it will return a new value to this property. So here on the main primary key, on the main primary key, we can have auto increment, and also we can have a value generator if we want. And in the composite key, we can have only a value generator if we want our primary key columns to be automatically generated on the insert. Also, we can have auto generate for another property. Let's say property description, product description, sorry. And we can add here a generator too. Let's move it to another line to be more clean. So new string value generator, and we can also, this will also run for the product description. It doesn't matter that the product description is not a primary key. We can add value generators to any property. The only constraint is that the value generator must be of the type of the property. For example, now we have made a string value generator, as you can see here, and it returns a string. So if I add this here as a new string value generator, which this property is integer, you see, we are having trouble. We are getting an error here. If I change this to the product category, for example, it will work. It will also work. So if we want a value generator for our integer column, we need to make a value generator that will create an integer, that will return an integer. But for now, let's just add here auto increment. All right, let's set this to true. Let's add these value generators here and save. And let's run. No, before I run, I want to show you a couple of more things. We have a new attribute here, which is the unique attribute. All right. So we can say that these two columns must have a unique combination in the table. All right. And we can add multiple groups. If we just type unique as I have typed it, then it will put these columns to the group 0. But if we want to create multiple groups of unique constraints, and let's add some more properties here so we can create multiple unique constraints to our database. Let's say product name FR in French, for example, product name and product name in French. All right, and let's make unique. And these two I want to be in a separate group, so I have to put a number here. If I put a number that is lower than 1, then this number will be turned to 1. So there's no point to add something as like 0 here, because 0 is taken from the unique attribute that has no number. So what we have made here now is a table with a composite primary key, which is this product ID and this product code. These two columns make the composite primary key, and let's move it here to make it more clear. All right, we have these two columns that are our composite primary key. Okay, and we have these two columns, which are the group unique group 1, and these two columns are the unique group 2. So we can't have the same combination again into our database. The SQL will not allow you to put the same combination of these two columns multiple times. All right, and also we have an auto value generator for the product code and an auto value generator for the description. And if we run this, we should have a table with a composite primary key and two unique groups. And we have an error here which says property product code of entity product is marked as primary key and it requires not nullable attribute. Oh, yes. I forgot to mention that in order to create composite primary keys, you need to mark the properties as not nullable. Sorry, I forgot that. So not nullable, not nullable. And since this has auto increment, I don't think it requires not nullable, but for security, let's add not nullable to both of them. So let's run this again. I hope we don't get an error now. And as you can see, now the black hole is checking everything. And now what it says? Property product name of entity product is marked as unique and it requires to be not null. Oh, really? Also the not null, also the unique constraints cannot have nullable columns. You're correct, black hole. So now it didn't make any changes. If we check here, if we refresh the database, all right, come on, we don't have the table product yet because it had errors and it didn't make any changes to the database, as I told you. And now I believe it's going to run. Now we have all the columns of this table to be not nullable. Perfect. And now I expect you to run and create the table. And perfect. So now that it's running, if we refresh here, we have the table product and we can check and see we have two primary keys. And if we go to the constraints, these are indexes here. All right, we have UC, unique product 0 and unique product 1, which are groups. Product group 1 has product name and product name for FR, which is to this group, and the other one is the product 0 group. BlackHole is capable of making tables that are fully controlled from the user, and you can set the primary keys, you can set unique constraints, and you can also add auto-generated values. At this point, I want to tell you that if you make unique constraints or foreign keys, BlackHole cannot undo this. If you change your mind later, you have to change the groups manually from the database using SQL. And now let's move forward and let's add a foreign key to point at this entity. So let's go to the order line, and here we can add, let me add these to the order line here, and let's paste these two here. And now what we need is to remove these attributes because we don't need them, and we need to add a foreign key. When we have a composite primary key, we also need two columns to point to those primary key columns, all right, in order to make a foreign key for to point that table. So foreign key type of product, and here also we need the foreign key type of product, but in this case, because product is not a black hole entity and the foreign key doesn't know what's the name of the column that we are pointing to, we need to specify here by string the name of the column. Alright, so we need here the product ID column, because here in the product we have product ID, and here we need the product code column. So we need to specify the names by string. I know it's not safe because you can make many mistakes with naming here, but there's no other way, because foreign keys for attributes in .NET didn't support generic types until .NET 8, and now in .NET 8 that they support generic types, they don't support a function in the constructor. So even if I change it in .NET 8 and I say add a generic type here, something like this, I still cannot use a lambda expression here, so it's pointless to do it. If Microsoft fix it, if Microsoft lets you add functions in the attribute constructor, then I will be changing this in the future, in future versions. But for now, we only need this, and let's also say that this foreign key it's not nullable. Let's say this is false, and let's say this is false too. All right, and let's run it to see what's going to happen. So let's run this. It takes a little bit longer to run. So it runs, and now we got an error again. And here it says, cannot add a not nullable foreign key on an existing table. Please change the nullability on the foreign key attribute on the property product ID of the entity order line. So we cannot add a not nullable column, that is foreign key, on an existing table. And that's because BlackHole cannot create a column that has a foreign key on it, and also it cannot fill this column with the default value, because the default value will not point to the primary key that we want. So if you want to add a not nullable foreign key into an existing table, you need to do it manually. BlackHole cannot add a not nullable foreign key on an existing table. So let's go to our entity here, and let's change this to true, or we can completely remove this, and it will add the columns as nullable. And let's run again to see if we got any other errors. So let's run. Here, let's run it, and let's see if we have other errors. And we have, but this time it doesn't specify the error, and that's an error that occurs at the execution. So it says something went wrong with the update of the database. The database is not changed. Please check BlackHole logs to detect and fix the problem. And this error occurs when it passes all the checks and has an error in the SQL. So let's stop this here. Let's go to our database, and let's see, did we have any changes? First, let's check if it made any changes to the database. So we added 2 columns to the to the product table, to the order line table. All right, let's see, do we have these columns here? And we don't have the columns, so it didn't update the columns. So now let's go to the logs, and let's see, here we have a log, an error log. Let's open it. And here we can see column product code is not the same length or scale as referencing column. So what it says here is, and you can see here that we have a begin transaction, begin try, as I told you. That's why it doesn't apply any changes to the database if something goes wrong. And let's go here to the BlackHole, to the order line, and now I am going to explain why we had this error. BlackHole foreign key attribute was made to point by default to a BlackHole entity with a string ID. Alright, so if you add a foreign key on a string property, it goes to point to, it thinks that it's going to point on a BlackHole entity with a string ID. And because the string ID column of the default BlackHole entity is 50 characters in length, that's why the default foreign key here thinks that it's going to point on a column with the default length of 50. But because here in the product we didn't specify the length of this property, all right, this string property, we didn't specify, we didn't add a varchar size here. This column on the table has 255 characters length. So our foreign key here, which is 50 characters length, does not match with that column. So here we have also to specify the varchar size, and we can say 255. But if we don't know the default varchar size of the BlackHole, we can also just say varchar size, and it will give the default varchar size. This will override the foreign key varchar size, and it will add a column with 255 size. So let's save and run this again, and now it should work. And as you can see, it passed everything, and our application is now running. And if we go here and let's refresh, let's open the tables and go to the order line table. Let's go to the columns, and as you can see, we have these two foreign keys. And if we go to the constraint, not the constraint, the keys, you can see we have two foreign keys. And here we can see that these two foreign keys are referred into this key here, the order line to product, all right? And this one is referring to this, the order ID. So these two columns are a composite foreign key to the composite primary key of the product. So now let's go and use this open entity, and let's go here to the ESOP service that we have created in the previous video, and I have made here a product generator, which is for the product, which is an open entity. And as you can see, I create only the product category, which is just a number for now. All right, I will be inserting a number here of the order line, and a product name, and a product name in French, for example, and I say here English name and French name because this combination has to be unique. All right, and I didn't include any other properties, because if we go to our ESOP entities here and go to the product, we can see that this property has auto increment, as we have set here, and the product code has a generator on it, and the product description also has a generator. So we don't need to add these properties into the, we don't need to set the values to these properties on the entity, because they will be automatically generated on the insert. So let's go here. We have these three properties, and we want to add a product to its order line. We want to generate a product for its order line because we have added foreign keys from the order line to point to the product. So let's go here. And now I see I also have a product name in the order line. Okay, let's ignore this for now, and let's go here and say product, the product. So I don't know, a product equals product generator, and let's put here the I. All right, because we want all this to be unique. And now we need to insert this, and to insert this we need to use the data provider for open entities. So let's go up here and let's create a data provider. Let's say private read only IBH open data provider. That's the new provider that takes inside a BlackHole open entity. All right, so here we say product. We don't need to specify any ID like in the other providers, because open entities don't have a standard ID. And let's say product service. All right, and let's use the dependency injection here to add the service. And now we can say here product service dot, and now I want to show you the methods, because in the open data providers there are missing some methods. The open data provider has half the methods of the normal V8 data provider, and that's because we don't have a specific ID column. So all the methods that are referencing the ID, like the get entry by ID or update entry by ID, these methods are missing. And you can, if you want to get an entry by ID, you need to say get entry where, and here you have to specify that the product ID equals some number. That's how you get by ID in this open data provider. You only have the link queue. You don't have ready methods for that are working with the ID. But for now we want to insert the product that we created. So we will say insert entry, and we will insert the A product here. And now I want to add a breakpoint here and one breakpoint here, and we will go to test it right now. And I want to show you that when you insert an entity here, when you insert, the values that are missing, and they are going to be generated by the data provider, they will be mapped on the entity. So then if I use here, if I want to use these properties after the insert, they will have a value inside. And let's run this. And I'm pretty sure that I have to remember how to call this method. Let me check. All right, it's running. Come on. give me some access here. So let me remember. Insert order for customer. Okay, so we need a customer ID here, and to use the insert order, to use the insert order for customer, we need to call which endpoint, this one, the insert order. All right, so I need to go here to the customer and select all the rows, and I need to take the ID of the customer. We inserted one customer earlier for to show you how you can add a not nullable column. And now let's go here. We have copied the ID and we want to post. We want to insert a order for the customer and execute. And now we are here. You can see we have created a product which only has, do we want the 0 here? Maybe, yes, we don't mind if the category is 0. Okay, and now we should see all these values, the empty values that we're expecting the generator to generate on the insert. We should see these values to be filled with data. The product code, the product description, and the product ID. So let's continue. And now, as you can see here, because it's the first product and it has auto increment, it got the ID 1, and the generator generated the datetime now to string. So it added the values here. And now, now I should have included here the required columns for the foreign key. So I made a mistake. Let me fix it really quick. So I am back. I have cleaned the order and the product here. So we can run the test, and I also added the product ID and the product code as references to the order line, so we can connect them with the foreign key. And let's run this again. And I also think I need to get the customer again. Let's select the customers here. All right, let's take the ID of the customer and let's go to our API and insert order, put the ID of the customer here and execute. And yes, we have a breakpoint, sorry, and we are going to see this again. I think this time it's going to take the number 2 as an ID because I deleted the number 1, but it's still there for the auto increment. Yes, we got the product ID 2, and now here it's going to take a product ID 2 as a foreign key and the product code, which is this datetime now. Let's continue, and now it's going to generate a different key because we have many orders. We have 5 orders here, so this time it has 3 and it has a little bit different datetime. And I am going to remove these breakpoints here just to let it finish. And we got our IDs here of the order lines, and if we go to the order lines, we can select all of them, and we can see that our composite foreign key works. And if we go to the products, we can see that all the columns are filled with the data and the generator worked, and it also is returning us the auto increment ID after the insert, and it's mapping it on the entity. And in the future versions of BlackHole, I may add this this functionality to the regular BHOpenDataProvider, and I could remove the integer that it returns, the ID that it returns, and I could instead return a true or false if the insert has been successful. Now, one last thing I want to show you, because as you can see, this is how you use the data provider, and we have also almost seen everything about the open entity. We have seen the unique constraints, the composite primary keys, and the auto-generated values with the generator, and the composite foreign keys, of course. One last thing I want to show you, but I don't think we can run it. We can. I will try to run it. So here we have a join that returns an order line to customer DTO. If I remember correctly, this is the execute query, so it returns the DTO directly. It's not the view. And now we could take some properties from the product, let's say here, and let's say we want these two properties. No, let's take these two properties, or let's take this. All right, let's take these properties, copy, and let's put them to the DTO customer order lines of customer. All right, let's go here. Let's put these properties here. We don't need this attribute because it is a DTO. And now I think we could join the product to the order line to the existing query here. So let me find the order line already exists, right? Yes, this is the order line is in the service. So we could just go here at any point, and let's say inner join, and let's inner join the order line, all right, to the product, all right, using let's start with an integer, and of course we also need the order lines of customer DTO. And to let you know, I am making a version for Unity and for .NET Framework, and I fixed somehow that problem, but at the cost of the cast. So I have made a better version of the join sequence without requiring you to declare all of these every time, but because you don't declare the DTO from the beginning, you cannot cast properties to DTO, and you declare the DTO in the end at the execute query, and then it starts mapping the properties. And yes, it's cleaner, but it misses the functionality of the casting. So this should be okay. And now we want to join the order line at the product ID to the product ID actually of the product. And because we have a composite key, and let's also join on the product code to the product's product code. And you see the names are the same because we did copy paste the properties from the product to the order line. But if we go here to the X, you can see here we are referring to the product, and in this X we are referring to the order line. So these are two different classes, two different entities there. So I expect, since I have added these columns here, I expect them to be included to the final join. Let's run our project and let's hope it's going to work. But as you saw, there is no restriction of using the open entities along with the default black hole entities to perform joins. So let me remember which endpoint it is. It's a customer order line, it's called. All right, customer order line. This should be it. Oh, and again, I need the customer ID, which it should be here. All right, George. All right, George. Let's see. What did you buy, George? So execute this and interesting. Did we have an error? All right, I figured out the problem. The problem was that we don't have any bonus points or discount, so it was an inner join here, and since we didn't insert any bonus points or any discount, it couldn't join them. It would find nothing, and I was getting no errors here except from the error that we got earlier from the update. So I didn't know what was wrong, and it was this line here because we didn't have discount. We didn't insert any discount to this tutorial. So now I have run this. Let me refresh actually. Let's run this again so you can see it, and customer order lines, try it out. So we will paste here, we will execute, and now as you can see we're getting the product ID and the product code, and the join between the default black hole entities and the open entity works normally. So that's almost all the new features of this new version of BlackHole. And I just want to show you one last thing, which is the parsing. Since we have open entities now, the parsing of the CLI when you want to parse a database, it doesn't have the same restrictions as before. Now BlackHole can parse any database because of the open entities, and it can parse tables without primary keys, or with composite primary keys, or with primary keys with different names, and it can understand which entity is default black hole entity and which one is not. And if you are parsing an old database, it's going to parse everything as an open entity, because this database would not have been created with a black hole. So let's test the parsing here. I think I have deleted the folder of BH entity, so we can run a parse command here. So let's go here to the package manager console, and I think I've saved everything, and now we just need to run BHL parse. And you see I'm not even using the force command because I think I don't need it anymore. We don't need the force command for the parsing anymore. So let's run this. Okay, and we expect to see a BH entities folder to be generated in our project with all the entities that exist in our project. So it starts running, and you see it's parsing the entities, and what it says here: project run finished successfully. And what else? The database is fully compatible with the BlackHole.Core.ORM. Of course, every database is compatible now. And here we can see all the entities. And if we open, for example, the order line here, we are going to see also, look at this. It also detected that this is a virtual size 255 and added the foreign keys that we have added. And also here, it also added the column. I remind you that if you're using only black hole entities in your project and not open entities, you don't need to specify the column because the default foreign key knows that the column is going to be named ID, but the CLI process just adds all the columns. So you can see here we have a black hole entity. So it detected that this table was compatible with black hole entity, so it created a black hole entity here for the order line and for the order, for example, you see, and it also detected what type of the ID was that. And if we go to the product, you are going to see here that it created an open entity of the product with not nullable columns, as you can see here. Of course, it cannot yet detect the unique constraints, and you don't need the unique constraints, the unique attributes to make it work, because the unique attribute is only used when you create a database, and then it doesn't matter for the black hole. It never uses it again. So if your database exists already, you don't need to have in your code the unique attribute. You can just know by your database that this column, some columns are pairs and have to be unique. So you don't ever use the same combination of values there. Also, it detected the primary key, and it detected that it has auto increment, and it detected the composite key. Of course, it doesn't know about the auto-generated values because the generators are running on the program and they're not on the database, so it cannot know. But if you want to add here a generator, you can add it. So that's how the parsing works. As you can see, it parses it parses everything correctly, except from the unique constraints and except from the auto-generated values. It just reads the database and it generates entities out of this. So yes, we can see these are all black hole entities. And that's all I wanted to show you in this tutorial. These are the new features that take the black hole to a next level, because now the developer has more options on the entity and on the database. And of course, I know this is a bit more complicated, and the generators and this method here is complicated, but it is not required to use this entity. If you are a junior developer and you don't want to mess with all this stuff and all these foreign keys, and all, you have to check the virtual size, for example, or make composite keys. If you don't need all this stuff, you can still use the regular default black hole entities. So that's all for this tutorial, and in the next video I'm going to show you a new version of black hole, which is for Unity game engine, and it's also for I'm going to release it for a .NET framework for simple applications that for Windows services, for example, or small applications for Windows. And this version is going to support only Sqlite3 to be compatible with the Unity game engine and the mobile and all the operating systems, and of course with Windows if you want to make a Windows service or a desktop application and you want to store a little bit some data there. So that's all for this video. Thank you for watching, and we'll see you.